All right, we'll go ahead and get started. As we go through, I'll take questions, so we'll try to make this dynamic to the extent that's possible in this, this exciting environment. I'm Doug Taylor. Last year I had the fortunate, we were up on a main stage, and I was able to convince the audience to do a wave. Now, I don't know that that'll work effectively in the room. And so I was thinking about, what are we going to do, right? We've got a conversation to talk about making OCP available for everyone. So I thought maybe we would sing a John Lennon song about power to the people. And then I realized that's probably going a little too far. Number one, I can't sing. So I was hoping we could at least get a shout out, a 1, 2, 3, power to the people, right? 1, 2, 3, power to the people. Awesome. Thanks for playing along. As I mentioned, I'm Doug Taylor with StackVelocity. StackVelocity is kind of an interesting combination of capabilities within Open Compute. We are an Open Compute solution provider. We are also an Open Compute manufacturer. So we provide both capabilities to our customers. We have customers that are OEM customers, and we have customers that are end users. And we try to balance that and take advantage of both markets, both sets of customers, to make sure that we're developing the best solutions appropriate for the market. StackVelocity is actually a business within Jabil Circuit Corporation.
In the world of Open Compute Project, where all the members are giving their hearts out to ensure prosperity.
That's not me. That was exciting, though. StackVelocity is a business within Jabil. Jabil Circuit is actually a global manufacturing company, been in business for many, many decades. 101 manufacturing locations globally, over 60 countries. And so we have the fortunate ability to leverage that globally. But it is actually StackVelocity in each of those locations that is operating. Those are our people, or our equipment, our lines, et cetera, that are going on in those areas. So it's pretty extensive in terms of our ability to control and ensure that we're delivering successfully for our customers. We have a full suite of solutions that we enable our customers with, everything from starting with the reference architectures and through rack integration, doing full validation, software knowledge and capability as well, but then also, most importantly, helping our customers through the useful life of that solution. So supporting that while it's out in the field, regardless of what geography within the world it is, providing break-fix support, or call-in customer support as needed through the useful life of that solution. We begin, our conversations with customers back really kind of in that design phase, and we look at that as an opportunity for us to optimize and drive efficiency within our customers' environments. We do not feel it is necessary for us to reinvent the wheel, and in fact, we spend a lot of our time looking at capabilities that exist already in the market. We are unlikely to manufacture a whole bunch of motherboards. We're much more likely to take Open Compute motherboards that exist today and integrate those and deliver them in a way that delivers something new and unique in this space, as an example. We'll talk about some examples of what we're doing in that category in a couple of slides. We provide a full suite of integration capabilities. So we might pilot a rack integration project in San Jose, just down in South San Jose. We may then move that or migrate that to Memphis, to Hungary, to Malaysia, or to China, just depending upon what's appropriate for that particular customer and what's appropriate from a distribution and where it's got to land. So the nice thing about the way we operate is it's very easy for us to copy from one place to another. All of the same systems are used, all the same methodologies, all the same processes are used in every single site across the globe. And as I mentioned, our ability to now take that into market with our customers and support that on their behalf, or as an end user, come to their sites or provide them with stocking capabilities if it's appropriate, again, depending upon the type of use case. So within Open Compute, over the last year, we've been working on a bunch of different things, primarily around driving and making Open Compute more digestible and acceptable for our customers. That comes from a workload perspective is probably the biggest challenge. Today, we feel like a lot of times our customers are having to adapt their workload to Open Compute. The byte sizes, the form factors are really geared towards a very specific set of customers that obviously we're able to drive that, and we're gracious enough to contribute that to the community. We're all very excited about that. That's why we're here. But how can we now take that approach and expand that and give more capability and more flexibility in terms of how that gets used in the market? So we'll talk about that. And then how do we create pathways specifically for a customer to migrate out of their traditional 19-inch space into a 21-inch. That's not saying that we want every single customer to migrate. That's saying that for those that want to do that, we want to make certain that there's a landing place and an easy way for them to adapt that. And we need them to be cost competitive, right? It doesn't make any sense for this to not be a solution that is appropriate for them from an ROI perspective. It has to meet those requirements. They're not just going to adopt Open Compute because it's a great, sexy buzzword. It's not really very sexy, but you know, it is a buzzword anyway. And so that comes in two ways, right? So it can be just, you know, making certain that we've got optimized costs, but it's also about avoiding wasted space. When you're building up a rack level solution, you often are hitting a barrier of some type. You either have plenty of power and you've run out of space in the rack, or you've got plenty of space but you're running out of power, and so you've got to add another power shelf. But when you add the other power shelf, it consumes the extra space that you had, and so now you really don't have as much space left over, so you can't justify adding the other power shelf. So how can we kind of help affect those different categories? And then obviously we're also addressing kind of the, I call it more of a niche space, or kind of different smaller spaces in terms of what we can do to help those. I've got a slide, we'll talk about some of those examples. So hat-trick storage I've talked about in a couple of summits prior. We showed a prototype last year. We had the concept in Paris first announced, and we're now heading into production. So we're pretty excited about this. It's a big deal for StackVelocity. We think it's a big deal for most of our customers. It increases density for storage in an Open Compute environment by 50%. So in 2OU, you now can have 45 drives in that space, all of those hot swap. So it's delivered with 3 JBODs that slide out, just like the form factor is just like a triple compute, but in this case it's a triple JBOD. So you slide that out and the drives slide in from the side. No carriers, traditional model from an Open Compute perspective. Each of those 3 JBODs operate independently and can be connected to one server, connected to multiple servers. Each JBOD has 2 12 gig SAS ports in the front. So I can now split that JBOD across 2 servers, or create 2 channels, or get a greater performance with a smaller number of drives going to one server across 2 channels on a RAID controller or a host bus adapter. We also are enabling, if you look at on the picture of the dual zoning, in that 15th, 16th drive bay, we actually are supporting the ability to split that. So it actually has 2 SAS channels going to that drive position, allowing us to put 2 small form factor drives there that each operate independently. So when we go into split mode, one of those 2 goes to the top half, if you will, of drives, and the other goes to the bottom half. So when we split that, we have 7 + 1, 7 large form factor, 1 small form factor going to each of the servers, or multiple channels. It also enables us to have, in a 15 drive sled, 14 large form factor drives and 2 small form factor drives, or obviously across the full gamut, you extend that. Any questions on hat-trick usage? We'll talk about a little bit more on this in terms of the density, because having better density from a storage perspective isn't really what it's about, right? What it is about is enabling you now to fit more solutions, more workloads in that rack. Because now I can take and fit 50% more storage solutions, so I can have more servers attached to storage. And so you see the increases, and I was trying to be pretty careful about being honest about all of the different comparisons, so that some of the solutions that you might deploy in these might cross power shelves and might do some things we might not choose to normally do, but I didn't worry about those little nuances as I was doing this. This is kind of max density capability here. So we begin to approach now a typical 1U space in terms of density. So 36 1Us. Again, now this is assuming we need storage. We need 7 or 8 drives, large form factor drives per server. And so now I can approach the density of a 1U. In a 2U12, right, a typical Hadoop storage solution, at least that I dealt with in prior lives, now I can deploy 15 drives or 14 with 2 small form factor drives, but I can now put 27 of those in an open compute rack. That's pretty exciting. As you get into the larger capacities per compute for cold storage applications, any kind of archiving, anything where you have a large data set that you're spreading around, that is when you really get significantly increased densities over traditional capability, and a service model that is much, much easier than in a 19-inch realm. Typically, you're doing top-loading drives which work up to a certain point in the rack. And then it just becomes very, very difficult, both from a weight perspective as well as from just how do I get to that top system within the rack. So these actually, you come in from the side, so it's a lot easier to service those. One of the other areas that we focused on is actually the rack solution itself, including the power shelf and the power densities. The challenge that you face in the market is how do you get to the level of power density that matches your workload and not just get stuck at a particular threshold. And so there's a number of different options that we have. Lighton is one of our core partners here that we're showcasing in our booth, and enabling a very significant capacity within the rack itself. And there's a number of different configuration options, a number of different use cases for that. But the key here is not getting stuck at that 12.5 kW threshold and forcing you into another shelf. Sometimes just having a little bit extra power gives you that ability to kind of fill out your solution within the rack. Taking the concept of hat trick now and applying that into the typical customer use case, we looked at, all right, so if my customer doesn't want to deploy in multiples of 3, how do I optimize a solution for that customer? And so hat trick is simply a way to deploy, frankly, 1 2.0 chunk at a time to meet your customer's requirements. So in the top picture, you'll see we've taken out 2 of the JBODs and replaced it with 2 compute sleds. In the bottom one, we replaced just 1 with a compute sled. That now means that I've got on the top, 2 servers capable of attaching to 8 drives, not including the drives that are inside the server already. So we have combinations with 3.5-inch drives inside, as well as combinations with 2.5-inch drives inside the compute sleds. They're open compute motherboard compatible, so any of the V3, V4 motherboards will slot right into there. It meets all of the standard specifications. The tray, the mechanicals itself, are unique to the implementation, but the actual motherboards, all the key pieces are all using the standard building blocks associated. And so it allows you to create a couple of different types of scenarios for different usages. We're working with our customer ASRock. For some reason, I made that a build in terms of the motherboards that we're demonstrating here today at the showroom, at the booth in the show. Again, the key is how can we make it more digestible? So the byte size now becomes a 2 OU byte size. So I can deploy my configurations 2 OU at a time. I don't have to worry about, in a storage-oriented environment, about having to deploy a big, potentially, 6, 8, or 12 OU chunk at a time to be optimized in that. So combining all of those, bringing in what's happening on the switch side, The wedge switch obviously being a key part of the future here associated with this, but bringing all those together, we actually get to a point where in many use cases, we are seeing comparable solutions to those that customers are experiencing on the one use side. Obviously, there'll be all kinds of variability there, and I'm not going to promise you that every single thing it makes a lot of sense. But in a lot of cases, we're seeing solutions that actually are achievable and appropriate to migrate from a traditional 19-inch environment over to an open compute environment. We've been doing a lot of work also on the open power side, and we actually have a 2-socket, 2U, 24-drive open power box that we've developed with open power and that foundation. That's actually the Saba that's on the right there. And we're also working with the Open Power Foundation to enable access to Barrel-I, which obviously, hopefully everybody knows, Rackspace and Open Power have been working on for a while to bring to the open compute environment. So as an open compute solution provider and a member of the Open Power Foundation, we can actually bring the best of both worlds together and deliver that in an open compute environment. We can also deliver, obviously, Saba in the traditional 19-inch environment. The open compute bridge rack is actually out in the hallway behind this particular room. And another important work that we've been doing with Fidelity and the bridge rack team to enable that and enable more options in that market. And that's a 28-inch wide form factor for that one, convertible from 19-inch to 21-inch. And again, just easy way to be able to adapt that. We have versions that are welded and versions that are flat packed, depending upon what's appropriate, again, in terms of the cost targets, et cetera. The bottom one's pretty interesting. So we've been working with Jean-Marie and Horizon over the last couple of years, since really the Paris event. And they've had this rugged pod concept, and we've been working with them. We actually are the manufacturing partner for Horizon Systems, and actually working with them on the mobile tower concept project that they did and did the mechanicals associated with that. I'm not going to claim that we did any of the IP around that from a design perspective. They are driving that, and we're excited to be a part of that. It's another way that we can help and enable and be involved in open compute and some of the ways that it extends beyond what you might traditionally expect in the space. When we think back and we talk about StackVelocity, right, I think that the main thing I want you to understand, we have a tremendous capability both within StackVelocity and then what is behind us from a Jabil perspective. We have a significant engineering capability, both from a design all the way through to a manufacturing capability. And we work with our partners in the environment and have had great success delivering integrated solutions for them, integrated solutions for our customers, and kind of leveraging the both of both worlds as a manufacturer as well as a integrator within open compute and also outside of that environment as well. So that is what I had for today, and so I thought maybe I would just take a moment and open up for questions if there's anything around Hat Trick or around Hat Trick Compute, or actually any of the others. Prospects for the Buccaneers this year. I live in Tampa, so I care a lot about that because they are going to win, obviously. Right, so. All right. Well, thank you very much. I greatly appreciate it.